All right, guys. Now we're going to translate into something called a piecewise defined function. This right here gives students the most trouble because it's a different type of function than we're used to dealing with because it's made up of different functions. So, definitions of piecewise defined functions are functions that are defined by different equations based on the set of restrictions. Now, if you look at this first one, when we're going to evaluate the piecewise function for the given values of f, and f is defined as three different equations. F of x is equal to negative x minus 1 for all x values that are less than negative 1. F of x equals to negative 3 for all x values that are between negative 1 and positive 2, where negative 1 is included. And it says f of x equals to the square root of x minus 2 for all x values that are greater than or equal to 2. So I want to show you how to determine which one is which for that equation. Now we want to evaluate this f of negative 2. In this case, the x value is negative 2. Take your x value and see which restriction works the best. For example, negative 2, right? Is negative 2 less than negative 1? The answer is yes. Negative 2 is less than negative 1. Is a different color. Is negative 1, is negative 2 a value that is between negative 1 and positive 2? The answer is no. And we know that negative 2 is not greater than nor equal to positive 2. Which one works? The first restriction works, yes, which means you're going to plug in the value of negative 2 into the first equation. So f of negative 2 will equal to negative inside parentheses, input the negative 2, subtract 1. Two negatives makes a positive. So now we have 2 minus 1, which is 1. And that is the answer for f of negative 2 in my piecewise defined function. Now we're going to reset the restrictions. Reset. For the second one, x is equal to negative 1. We're going to see which one works the best. So we're going to plug in negative 1 in for x on according to my restrictions. Now, is negative 1 less than negative 1? No. A value cannot be less than itself. Is negative 1 a value that is between negative 1 and positive 2, where you can include negative 1? The answer is yes. Because if you look here, negative 1 can be equal to negative 1. That's why that one works. And for the last one, can negative 1 be greater than positive 2? The answer is no. Therefore, the second equation works. And it says that f of negative 1 would just be equal to 3. You can't plug in negative 3, excuse me. You can't plug in any other value, so we just leave it as negative 3. That's it. Okay, reset. So, the next x value is going to be positive 1. X equals to 1. See which restriction works out the best. So, place the 1 here, the 1 here, and the 1 here. We already know that 1 cannot be less than negative 1. No. Positive 1 is a value. Yes, it is a value that is between negative 1 and positive 2. And 1 is not greater than 2, which means we're using this equation again, which means f of 1 equals to -3. And that is the answer. Now let's reset one more time. And now the x value we're focusing on is going to be positive 2. X equals 2. So we're going to plug in 2 into the restrictions. 2 here, 2 here, and 2 here. Can 2 be less than -1? No. Is 2 a number between -1 and positive 2? No, not in this case, because 2 cannot be less than 2. But can 2 be greater than or equal to 2? Yes. Although 2 cannot be greater than 2, but 2 is equal to 2. Therefore, I'll be using this bottom equation, which will equal to the square root of 2 minus 2, because x is 2. Use a different color. Square root of 2 minus 2. And 2 minus 2 under my square root is 0. The square root of 0 is just going to be 0. Let me get rid of the square root sign since I don't need it no more. And that is how I evaluate my piecewise defined function in the simplest way. I took my time doing this. Once you guys get comfortable with it, you can breeze right through it. This could have been done in about maybe 2 minutes tops. But get comfortable with it before you breeze right through it. All right, guys. In the next video, we'll see how to graph a piecewise defined function, which takes more skills and more patience to do. We can definitely do it. I'll see you soon.